Hello everyone, welcome to StudyIQ. So in the previous video what we have seen is, we have seen the method of finding the LCM by using prime factorization, right? So we have seen the LCM of 60, 72 and 96 by using the method of prime factorization. 60 you will write as 4 into 15, so it's actually 2 square into 3 into 5. 72 you will write as 8 into 9, so 2 cube into 3 square. 96 you will write as 32 into 3, so 2 raised to 5 into 3. And LCM, I told you, everything which is involved in this prime factorization, that is 2, 3 and 5 with the highest power. So 2 highest power is 5, 3 highest power is 2 and 5 highest power is 1. So this is your LCM. But when it comes to HCF, you will take only those common terms. Right, so 2 and 3 is common, and how much 2 is common? Here only 2 2's, right? So 2 square into 1 3. That's what your HCF. Now finding HCF, I have also given you one shortcut method, that is just by taking the difference between these two, right? That is 12, and that's your HCF. But you cannot conclusively tell in all cases that the smallest difference is your HCF. Not just the difference, the smallest difference. You need to check it, right? So how will you check? You can divide. And the methods I have discussed, the logic also I have discussed in the previous video. Now, the other method is actually the long division method that you used to do. It's like, you will write it like 60, 72, 96. Then you will divide like this, right? You'll start with 2. Why? Because 2 is the first prime number. Then you'll get 30, 36, then 48. Again you will do with 2. Then you'll get 15. You'll get 18, you'll get 24. Further continue with 2, you will drop 15 like that because you cannot divide 15 with 2. Then 18 you get 9, 24 you get 12. Still there is one term which is a multiple of 2, so you continue with 2. 15 you drop like that, 9 you drop like that, 12 becomes 6. Further again 2 because one term is a multiple of 2, then it becomes 15, 9 and 3. Now there is no multiples of 2, so you need to proceed with the next prime number. So you'll go with 3, that is the next prime number. So you get 5 here, you get 3 here, you get 1 here. Again there is one multiple of 3, so proceed with 3 again. This 5 you will drop like that, 3 become 1, 1 is 1. Then 5, right? So what you got here is your LCM. Okay, so this is what your LCM, and that's what 2 raised to 5. Like here 2 is there for 5 times 3 square, 3 is there for 2 times and 1 time 5. If it was HCF, what you will do? You will only find the common terms, right? So 60, 72, 96. You will divide with 2, you get 30, 36, 48. Further divide with 2 because 2 is common in all. You get 15, 18, 24. Now you cannot divide with 2 because 2 is not there in 15. You need to see a prime factor which is there in all the 3 terms, right? So what is there? Now 3. So this becomes 5, this becomes 6 and this becomes 8. Now there is nothing common, so you'll stop it here, and this is what your HCF, 2 into 2 into 3, and that's what exactly you got here. And that's what exactly you got when you're taking the difference between these two, the smallest difference, 60 and 72. I hope this is clear. So basically this, you should not do this. This is time consuming, and this is not suitable when you are taking an aptitude exam. Okay, always try to prime factorize it faster in your mind and try to get the LCM and HCF. HCF you can find by just taking the smallest difference, but you need to check it in all cases. Okay, but in most of the cases, 90% of the cases, the method will work just like that. Now if you want to have more clarity, let me take some simple number. Let's take 6 and 20. Okay, let's understand LCM and HCF through prime factorization by using a Venn diagram. Okay, let's visualize. Okay, so let's visualize in a Venn diagram. So what you will do, 6 you can write as 2 into 3, and 20 you can write as 5 into 4. So basically 2 into 5, right? Now if you make a Venn diagram for the 6 and 20, how will you make it? So this is 6. Okay, let's make a bigger diagram for 20. So let's keep this as 20. Okay, Now, what is common here? If you see here, 2 is common. in both, right? So let's write that 2 inside. That is common for both. What is left out? 3 is here. Let's write that 3 here. 2 and 5 is here. Let's write that 2 and 5 here. Now what is your LCM? If I ask you what is your LCM, you will have to write everything which is there in the Venn diagram. So basically 2 into 2 into 3 into 5, and that's what your LCM. Everything in the Venn diagram. What if I ask you what is HCF? You will write only the common term, that is this one, right? That 2. So 2 is your HCF. I hope this is clear. This is how you can understand LCM and HCF in a Venn diagram. Now, what if I ask you LCM of fractions? It's like if I give you two numbers, 3 by 7 and 6 by 8, something like this. Okay, so what is the LCM of these two? Or if I give you numbers with numerator and denominator, let's suppose n1 d1 and n2 d2, etc. Okay, maybe d1 and d2 may be common. Okay, so generally you understand LCM of fractions or rational numbers. Now I already told you, if you take 3, 3 also is the rational number. Why? Because 3 by 1 I can represent in the form of p by q, where q is not equal to 0. But here I am only talking about those numbers which is having a denominator other than 1. Okay, if the denominator is 1, that is actually integer itself. If the denominator is 1, that is actually an integer. So I am talking about fraction, that means the denominator is not 1. Okay, so any other denominator. So basically I just want to give you the information directly. LCM of fractions. So LCM of fraction. So what is required to find out LCM? So in your answer also, see here you have it, fractions means numerator and denominator. So in your answer also there will be numerator and denominator, right? So in numerator what will come, in denominator what will come is what you need to know. In numerator it will be LCM of numerators. So there will be two fractions which is given. So there will be two numerators and two denominators. So LCM of numerators divided by HCF of denominators when you need to find LCM of fractions. So if you need to find LCM of fractions, numerator will be LCM, and that's what you need to find out, right? Denominator will be HCF. Now obviously you can tell me, what if you need to find HCF of fractions? What will be the answer? You need to find HCF of fractions. So what will be the numerator? HCF of numerator divided by LCM of denominator. So no need to have any confusion. You have two fractions. Let's suppose 3 by 7 and let's take 5 by 9. Okay, so I am just taking two random numbers. Okay, so if I ask you to find LCM of these two, what is your answer? LCM of numerators. So numerator means 3 and 5. What is their LCM? That is 15. Divided by HCF of denominator. 7 and 9. What is HCF? Just take the difference between those two. 2 is the difference. But 2 can't be my HCF because 7 is not divisible by 2. So what is the only possible answer? 1. So what is the HCF? HCF of denominator is 1. So what is the answer? LCM of this 2 is actually 15. What if I need to find HCF? Numerator will be HCF. So HCF of numerators. What are the numerators? 3 and 5. What is HCF of 3 and 5? That is also 1. The reason is the difference between them is 2, but 3 you cannot divide with 2. So the only possibility is 1. So 1 is the numerator divided by LCM of denominators. 7 and 9. What is LCM? 7 and 9, between them there is no common multiple. So obviously this is going to be 63. So LCM of this 2 is 15. HCF of this 2 is 1 by 63. Now, what if you have three terms? So then LCM of numerator divided by HCF of denominator in case of LCM, like maybe 3 by 7, 5 by 8, okay, and then 7 by 9. You have three terms, right? Three fractions. So if I ask you what is LCM? LCM is LCM of numerator divided by HCF of denominator. That I know. Now what if I ask you HCF of these three numbers? Numerator will be HCF of numerators divided by LCM of denominators. So let's find it out. Now what is LCM of numerator? Numerator is 3, 5 and 7. What is LCM? 3 into 5 into 7. Between them there is no common term. Divided by HCF of denominator. 7, 8, 9. What is HCF? take the least difference, right? So 8, 9 you get the least difference, or 7, 8 you get difference 1. That's your HCF, so 1. So your LCM will be 3 into 5 into 7. Now, what if the question is HCF? HCF of numerator 3, 5, 7. What is HCF? Take the smallest difference. 3 and 5, difference is 2. But 2 can't be your HCF because 3 is not divisible by 2. So what is the answer? HCF of numerator will be 1 divided by LCM of denominators. 7, 8, 9, between them there is no common factors. So 7 into 8 into 9. I hope this is clear for all of you. So this is how you will find LCM and HCF of fractions. Now the questions in detail we will discuss. Okay, I am going to discuss about the questions in detail. Okay, so I hope this is clear for all of you. Now one more interesting and important point which I need to tell you is basically you may get questions based on that. Let's suppose you have two numbers. Okay, so let's take 3 into 7. What is the product? 21. Okay, so 3 into 7, product is 21. Okay, let's hold it down. Now, if I ask you what is the LCM, 3 into 7, what is the LCM? Between them there is no common factors. So LCM is equal to 21. Now, if I ask you what is HCF of 3 and 7, 3 and 7, you don't find any common factors, so you'll tell me 1. Now, the point which I need to tell you is, if you multiply LCM into HCF, what you get is 21 into 1. That is nothing but 21. We already got a 21 here. What is that 21? That 21 is actually the product of two numbers. So what you can conclude is product of two numbers is equal to LCM into HCF. Very, very important. Based on this you can get questions and you need to solve it. So if you know this concept, many questions you can solve faster. So product of two numbers is equal to LCM and HCF. Now they will ask you to find HCF without giving numbers. See, I have taken 3 and 7 so that you will understand it much better and it will be very easy. And once you understood this concept, I don't believe in solving hundreds of questions. You understood the concept and you can solve questions. You can make questions rather than solving questions. Okay, so basically what question I can ask you, or you can make a question here. I give you just like this. The product of two numbers is 21. So there are two numbers A and B. A into B is equal to 21 and the HCF is equal to 1. What is LCM? So here you need to find LCM without knowing the numbers, right? But anyway you know the answer. LCM is 21. Why? Because product of number is equal to LCM into HCF, and product is given, HCF is given, so LCM is direct. Similarly they will give you product of numbers is 21, LCM is 21. What is HCF? HCF is 1. If I make different numbers, then you will feel it very complex. Then it become a complex question. But here it is very simple. Just because I have taken 3 and 7, and you all are very familiar and very easy with 3 and 7, right? So let me take a different number if you want, just for the sake of taking a complex number. Otherwise it's not required. Let me take 12 and 13. Okay. So what is the product? So basically how will you multiply this 12 and 13 faster? 12 into 12. What is that? 144. Everybody know that, right? So 13 means one more time 12. So 156. That's the product. I hope this is clear for you, right? Now, what is the LCM? LCM is basically 12 into 13 because among them there is no common factors. I hope you know this concept that we have already discussed, coprimes. Two consecutive numbers are coprimes because they don't have any common factors. Relatively prime number, except one there is no common factor. So two consecutive numbers. So here this is a product is 156, LCM obviously 156, HCF you just take the difference, so that is 1. So here also HCF is 1, so I can't make a difficult question here. So let's not take consecutive numbers, let's take two numbers which are having some distance. Okay, let's take 13 and 8. Or let's take some numbers where there is a common factor. Let's take 12 and 8. Then you may feel some difficulty. 12 and 8. Okay. So 12 and 8. Now what is LCM? LCM will be, how will you find? 12 is basically 4 into 3 or 2 square into 3. Okay. So 12 is 2 square into 3. 8 is 2 cube. What is LCM? 2 cube into 3. So that is actually 24. What is HCF? HCF will be the common That means 2 square is common. That is 4. HCF is 4. Now you can make a question, right? So LCM is 24. HCF is 4. You know this. All those informations are with you. You know the numbers also that you have taken. What are the numbers? 12 and 8. Now imagine that you are an examiner, and what you will do, you will tell your students or the person who is going to take an exam, you will not reveal these two numbers, 12 and 8. You tell that I have two numbers. Okay? The product of two numbers I will give you. What is that? Just multiply this 12 into 8. I know this, but the students, the person who is going to take exam, they don't know, right? So 12 into 8, product is 96. So I give you the product, 96. I give you LCM, that is 24. You will ask me what is HCF. So in fact, you are actually asking me HCF without giving two numbers. You have just given product and LCM. What is your answer? 96 by 24. You get 4. Similarly, the examiner can give you the product, that is 96, and HCF, that is 4. We'll ask you to find LCM, that is 24. I hope this concept is clear for all of you. Now, very important information which I want to tell you is, this is applicable only in case of two numbers. If you have three numbers, let's take three numbers. Let's take 12, 15, 21. Okay. So let me find LCM. What is LCM? So what is 12? 12 you will write as 2 square into 3. Right? Then what is 15? You will write it as 3 into 5. What is 21? You will write it as 3 into 7. So what is LCM? You will take all those numbers involved with the highest power, right? So your LCM will be 2 square into 3 into 5 into 7, and that's what your LCM. Okay, what is your HCF? HCF will be the common number, that is 3. Or without prime factorization, how will you find? Just take the difference. 12 and 15, 3 is the difference. And you can check 12 by 3, yes. 15 by 3, yes. 21 by 3, yes. So your HCF is 3. Okay, now this is 420, right? So now you can multiply LCM and HCF. So 420 into 3 is not equal to 12 into 15 into 21. You can do this calculation, but there is no need to do this calculation. This is not equal. I know this, right? So if there are three numbers, the rule is not applicable. LCM into HCF will not be equal to the product of numbers. But if it is two numbers, the LCM and HCF, if you take the product, you will get it as equal to the product of two numbers. So the product of LCM and HCF will be equal to the product of two numbers, and based on that you will get questions. Now if I ask you to find LCM and HCF of 92 and 510, okay, 92 and 510, how will you find LCM and HCF? You will prime factorize, right? So 92, how will you write? 2 square into 23, and that's what 92. 2 square into 23, 4 into 23. See, basically you will prime factorize like this. 2, you will get 46. 2, you get 23, and 23 is a prime number. You can't do anything with that now. So 2 square into 23. Then 510. 510 is actually 30 into 17. And 30 is 2 into 3 into 5 into 17. You can do like this. 510, if you want, you can do like that. But otherwise, you can directly write 30 into 17 if you know that. Okay. So that's what 92 and 510 prime factorization. Then what is your LCM? LCM will be, you take all the numbers involved, 2 square. So LCM is equal to 2 square into 3, 5, 17, 23, right? 3 into 5 into 17 into 23. That's your LCM. What is your HCF? What is common? Only 1, 2 is common, right? Here and 2. So HCF is 2. Now, if you try to visualize in a Venn diagram like this, so let's draw 92. What is that? 2, 2, 23. What about 510? 510 is 2 into 2, 3, 5, 17. Now let's join them with the common terms, right? So whatever is common, let's join. So this is 90. This is 510. Let me draw a bigger one for 510. This is 510. This is 90. So what is common? 2 is common. So 2 here, 23 here. Then what will come in 510? Rest of the area. 3 will come, 5 will come, 17 will come. So whatever is there in the Venn diagram, this total is your LCM, right? So this 2 and this 2 is what, this 2 square. Then you have this 3, 5, 17 and 23. What is your HCF? HCF is what is coming common. This 2 is your HCF. I hope this representation and this understanding is clear for all of you. This is how you can visualize or understand LCM and HCF in a Venn diagram. in this question, what you need to do, basically it's an example for the fraction, LCM of fraction question, right? So basically you need to find LCM of fractions, which is given 7 by 3 and 13 by 4. You need to find the LCM of those two, right? So LCM of fraction, you know, LCM of numerator divided by HCF of denominator. You know this, right? So LCM of numerator means 7 and 13. Between them there is nothing common. So 7 into 13 divided by HCF of denominator 3 and 4. What is the common difference between them? That is 1. So that's your answer. 7 into 13, 91. So 91 is your answer. In this question, you need to find the highest number less than 2000 which is divisible by 4, 6, 8, 10, 12. Okay, so highest number less than 2000 divisible by all these numbers. What is this concept? This basically is based on LCM. Why? Because divisible by all this. So what we have learned is LCM is the lowest number which is divisible by all this, right? So let's see what is the lowest number. And based on that we can find the highest number less than 2000 also, right? That is the idea. So if you need to find the lowest number, you need to find the LCM of these numbers, right? So 4, 6, 8, 10, 12. What is the LCM? So 4 you will write as 2 square. This you will write as 2 into 3. This you will write as 2 cube. This you will write as 2 into 5. This you will write as 2 square into 3. So what is your LCM? You will take 2 square from here. So 2 square. Okay, you have a 2 cube here. So you take 2 cube. Then you have 1 3 here, so you'll take 1 3. Then you have 1 5 here, so you'll take 1 5. So this is actually 120. So 120 is the LCM. What does this mean? 120 is the smallest number which is divisible by all these numbers. But what is asked? Not the smallest number, the highest number with a limit. Limit is 2000. Less than 2000, what is the highest number? Otherwise, if 120 is divisible, 240 will be divisible. If 120 is divisible, 1200 will be divisible. If 240 is divisible, 2400 will be divisible. Like this, there are many numbers. Okay, so we are looking for a multiple of 120 less than 2000. What you will do? You just need to divide 2000 with 120. See what is the remainder. When you divide, you will get 80 as the remainder. This remainder you subtract. That means you get 1920. Why this remainder? Because you have 80 extra from the multiple of 120. So avoid that. You get the multiple of 120 less than 2000. So what is that? 1920. So 1920 will be divisible by all these numbers. Next number divisible by all these numbers will be, if you need to find, you need to add 120. So that is actually 2040. That is greater than 2000. So the number required for us is actually 1920. So rather than dividing, how will you find it? 120 is the lowest number. So 120 is there means 1200 will be there. Then 720 is a multiple of 120. So you add 720, you will get 1920. If you add 120, this will cross 2000. So this can't be your answer. So 1920 is your answer. Or the other way in which you can find is, if 120 is the multiple, then 1200 is a multiple. Then 2400 is a multiple. Okay, but since 2400 is greater than 2000, subtract 120 and another 120, so 240, and another 120, so 360. So when you subtract 360, you get 2040, which is also greater than 2000. So subtract one more 120, so you get 1920. In any way you can find it. You will not face the difficulty in finding the answer for this. In this question, you need to find the least 3-digit number which will give a remainder 6 when divided by 8, 9, 10. So when you divide by 8, you get a remainder 6. When you divide by 9, you get a remainder 6. When you divide by 10, you get a remainder 6. So if you remember, we have discussed this question in your division questions, right? So what is this pattern? If I represent like this, n is equal to 8a plus 6 is equal to 9b plus 6 is equal to 10c plus 6. Then you will understand it better, right? We have discussed the same question. What is common here? This is type 1 that we have discussed. Pattern type 1 in division question. What is that? Remainders are same. In all cases, remainder is same. But obviously the divisors are different. What is your answer? LCM of 8, 9, 10 plus 6. This is also an application of LCM. That's why I put this question, right? So LCM of 8, 9, 10 plus 6. So what is LCM of 8, 9, 10? 8 I'll write as 2 cube. 9 I'll write as 3 square. 10 I'll write as 2 into 5. So 2 cube into 3 square into 5. That means 360 is your LCM. What is your answer? 360 plus the remainder. So 366 is the least number which when divided by 8, 9, 10 leaves the remainder 6. So 366, that means 366 divided by 8, what is the remainder? You get 6. You can check it. 366 by 9 will give you remainder 6. 366 by 10 will also give you remainder 6. So 366 is the only number which will give you remainder 6 when divided by 8, 9, 10? No. 366 is the least number. What is the next number? This concept also we have discussed. 366 plus LCM of divisors, that is 360. Then you add, keep on adding 360, you get the next numbers in the series, right? So you will get an AP with a common difference 360. Now what are the possible questions here? Any question which can be asked from an AP can be asked here. So they can ask you the first term, and that's what this 366. They can ask you 10 such possible number. So you need to, so if you generalize nth term, what is that? A plus n minus 1 into D. Or they can ask you how many terms. What is the answer? Last minus first divided by the common difference plus 1. We have discussed this, right? And they can ask you a question based on the constant remainder also. So we have we had enough discussion based on constant remainder. So if any one of you missed it, just go to the previous video and watch it. Okay.